Hello.
All right, here we are again. And so I see nobody forgot about daylight savings time. That's good. I guess that the time for that was yesterday. If you did forget, it was going to be yesterday, not today, most likely. Especially because all of our electronic devices automatically update themselves. But there's still the old watch that has to be rewound, and maybe the clock in your car. But here we are again. And so here's what we're doing today. We have two problem sets that we should be working on. And so we'll be doing that right now. Chapter 3 and 4 problem sets. And this is all a prelude to preparing for the midterm. Now, I just realized just now, I forgot to post it, but we're going to have also what I call my sample midterm, which is designed to get us ready for the midterm, which, if you recall, is entirely based on chapters 1 through 4. All right, so let's go back here, 1 through 4. All right. And then that basically covers everything we did up to and including supply and demand. After that, chapter 5, if you recall, was GDP. That will not be on the midterm. All right, that will come on the second midterm. All right, so for the first midterm, it's just 1 through 4 only. So for now, though, what we're going to do is we're going to just look at the problem sets for 3 and 4. I didn't write a separate one for 1 and 2. Those will be incorporated into the sample midterm. So like I said, even though I neglected to post it, I'll take care of that this afternoon. So I'd like to get the chapter 3 and 4 problem sets done today, and then we can focus on the sample midterm on Thursday. And then you can have the real thing. All right, something to look forward to? Yes, that's right. At long last, people are getting themselves a midterm. Now, yeah, we're about halfway through the semester, I guess. Of course, the timing is a little unusual because, we don't have our usual spring break, which we would have had. Although in the past, SUNY Purchase's their spring break was always quite a bit later than most other schools. I don't remember what the reasoning was behind that, but this year we don't have one at all. Although there are a couple of days off scattered throughout the calendar. I don't think that any of them affects us, though. I think there's a Tuesday off somewhere along the way and a Wednesday, but not a Monday or a Thursday. So we'll have all of our normal classes. So anyway, why don't we open up this chapter 3 problem set and take a look at it. Now, here's what we're going to do. Now, this first one is a table. We have a table which contains different combinations of hamburgers and steak that we could produce with the same resources. Okay, so I guess this is a bit of a stretch. Maybe they're not the same cut, but that's all right. We'll use our imagination and assume that beef can be converted into either burgers or steak. And so this chart tells us the rate at which we can exchange hamburgers for steak and vice versa. Okay, so what we're going to do is create a production possibilities frontier based on information, and then we're going to have to calculate all the different opportunity costs of moving between the different points on that production possibilities curve. So first things first, let me save this. What is today, the 15th? Yes.
Yeah.
Oh, that's right. You know what that means? Any minute now, it's going to be St. Patrick's Day. Woohoo! In fact, I saw somewhere on the internet in Chicago, I don't know if you're aware of it, but they will every year at this time put green dye into the Chicago River because it's so cool for St. Patrick's Day. I guess it's just something they've always done. And yesterday was Pi Day. That's right. You don't get as much celebration of that for some reason. I'm not sure why. That one doesn't seem to have caught on very well. But yes, mathematicians in the know will celebrate Pi Day, 3/14, of course. And so that was yesterday. And then later on this week, we'll have St. Patrick's Day. And
I know it was Einstein's birthday yesterday, I think.
Whose birthday was yesterday?
Einstein's.
Was it really? I didn't know that. Was he born on Pi Day?
Yeah.
That's pretty appropriate. Hmm. Wow, I didn't. That's pretty funny how that worked out. Uh, I guess the stars foretold his fate when he was born. Yes, young Albert, you will become one of the greatest thinkers in history. Math will be making your name for you. So let me get this over here. All right, so let's get this thing started. So now the drawing, you know, do your best. It doesn't have to be a masterpiece, but basically you just want to be able to show that you are able to create the curve. And it specifically mentions that you should have burgers on the vertical axis. Just this way, everyone's got the same graph. And steak goes on the horizontal axis. And so, you know, do your best. It's never going to be perfect. So hamburgers go up here, steaks go down here. And we have 5 points. What are they? Right here. So for example, point A means we have just hamburgers, no steaks. That's point A. Let's see if I can clean this up a little bit. Point B is 18 burgers and 2 steaks. Okay, let's see. I'll try to help myself here by drawing these little guidelines. Let's say this is 10, this is 15, this is 5. Oops, this is 5. So B would be roughly with 18 hamburgers and 2 steaks. Let's see, where can we put that? Let's make this a little smaller so I can see what I'm doing, or we can all see what I'm doing. Maybe not that small. All right, here we go. This is fine. So B is 18 and 2. Oh, here we go. Yesterday was Pi Day. What's 5 not 0?
The graph.
The hamburger axis.
Did I do something wrong on it?
Yes, it should go 20, 15, 10, 5. Right?
Oh, right. You're right. God, what was I doing? Yes, thank you very much. I wasn't sure what that was alluding to, like 5 not 0. Was that the name of a band or something? Oh, I think that would be a nice name for a band. It has an air of mystery to it, doesn't it? I like that. I think I'll copyright that while I'm thinking about it. All right. Anyway, yes, very good. Thank you for catching that. So we have 18 and 2. That would be roughly around here, let's say. Then we have 14 and 4. I guess that'll be about it. 8 and 6. Oops, no, sorry, that's the wrong one. 8 and 6 should be closer over here. Right about maybe here. And E would just be the horizontal intercept. So it's hard to tell from this. It's supposed to be a curve, for God's sake. Oh, okay. That'll have to suffice. It's meant to be a smooth, continuous curve. And you can see it's not, but that's good enough. Okay, so there's our curve. Yes, this is what we're aiming for. But the idea here is that it should be clear by looking at the graph that it's not a straight line. Okay, a production possibilities frontier typically has one of 2 possible shapes. It's either a straight line or it is convex to the origin. Concave to the origin. In other words, it's bowed out. And because of that, on this bottom one, with the straight line, we have constant opportunity costs. Here, though, when it's concave to the origin like this, that means it is we have increasing opportunity costs, which is what you would expect to see in the real world. Okay, if it was convex like this, you would actually have decreasing opportunity costs, which you would never see in the real world. So we'll let's just say we'll rule that one out. So there's your curve. Now, the challenging part is the calculations for these opportunity costs. So how exactly does this work? All right, well, first of all, for any opportunity cost you might be asked to calculate, they're asking you to calculate the opportunity cost of producing hamburgers. All right, so what they're saying is that what we're doing is we are, by increasing our output of hamburgers, we are sacrificing the opportunity to make steaks. Okay, so the opportunity cost of hamburgers equals, okay, and this is for any point you happen to be on the curve, the sacrifice steaks divided by the gained hamburgers. Okay, so anytime you calculate an opportunity cost, the amount you sacrifice goes in the numerator, the amount you gain goes in the denominator. Now, because we're sacrificing steaks to make more burgers, that implies that we're moving up the curve. In other words, the only way this can be happening is if we're moving along from E to A. Because it's in this direction that we're gaining hamburgers and we are sacrificing steaks. So, all right, why don't we do this? Let's, here we go. I'm going to split the screen in half so I can see the chart at all times. So we'll start at point E. Okay, so the opportunity cost of making more hamburgers, this implies that we're moving to point D, by the way. Okay, so I'll make the note of that here. Starting at point E and moving to point D. What's happening is that the opportunity cost is equal to, all right, so we go from E to D. We're going to lose 2 steaks. And we're, God, all these ads that keep popping up on my screen, it really is annoying. But one day I'll figure out how to get rid of them. Anyway, so it's the sacrifice steaks. As usual, I mean, this is what we said before. But in this particular case, it's equal to, we lost 2 steaks, okay, and we gained 8 hamburgers. So we could think of this opportunity cost as the sacrifice of 0.25 steak per hamburger gained. All right. So in other words, each extra burger that we were able to produce required the sacrifice of 1/4 of a steak. Okay. Now, in this case, actually, this is not a terrible example. I'll tell you why, because what's happening is that, and I don't really know enough about this, but I know that burgers and steak are made with somewhat different cuts from the same cow. And so what's happening is as we move and try to make more of one, we're trying to use a progressively less appropriate material for the other one. So the opportunity cost will just keep growing. So as I move from point D, and again, what that means is moving from D to C, the opportunity cost of the hamburgers equals, and I probably shouldn't repeat this every single time. It turns out that what's happening is that we're, again, sacrificing 2 steaks. This time we're only gaining 6 burgers. Okay, so it's 2 over 6, which is 0.33 steaks per hamburger. And as we expected, already we're seeing a pattern developing here as we move up the curve and we try to make more and more burgers, the opportunity cost is steadily increasing. And that's exactly what we would expect. All right, then point C, by which I mean moving from C to B, means the opportunity cost of the hamburgers this time we lost another 2 steaks, but we only gained 4 hamburgers. All right, so we have 2 over 4, it's 0.5 steaks per hamburger. And then finally, from at point B, by which again I mean moving from B to A, we have the opportunity cost of hamburgers. So, and then with this last step, we lost 2 steaks and we only gained 2 burgers. Okay, so here we have 2 over 2, which is 1. All right, so that's the complete set. All right, that's it. Oh, I forgot to write steaks per hamburger. All right, so just as we expected, the opportunity cost continues to increase as we try to make more and more hamburgers. Okay, so that's all we need there. And, you know, we can make a little comment here that as we continue to increase our output of hamburgers, the opportunity cost in terms of sacrificed steak steadily increases. And that's precisely what you would expect to see. Okay. Now we're going to go the opposite direction. We're going to try to figure out the opportunity cost of the steak on each point of the curve. Okay, so the opportunity cost of the steak, this works in the opposite direction. So by increasing our output of steaks, we are sacrificing the opportunity to make hamburgers. The opportunity cost of the steaks, as you can probably guess, is the sacrificed burgers divided by the gained steaks. Oops. All right then. So if you look at the curve, that means we're going the opposite direction. We'll start at A and work our way down to E. Okay, so we'll start with A. And actually, let me copy this chart again so we don't have to keep scrolling around all over the place. All right, very good. Oh, let me get rid of these hours because now they're facing the wrong direction. All right, very good. So starting with point A, and that of course means moving from point A to B. The opportunity cost of the steaks, the opportunity cost of the steaks is of course the sacrificed hamburgers divided by the gained steaks. And in this case, that would be, as we move down, Hold on. Okay, so what's happening is we're moving in this direction. Okay, so in order to figure this out, that means the sacrifice of hamburgers is 2, and we gain 2 steaks. So it's 1 hamburger per steak. Okay, so at point B, which means moving from point B to C, this equals, now we're going from B to C. And ooh, what's happening here? We gave up 4 burgers to get 2 more steaks. That's 2 hamburgers per steak that we're giving up. Okay, and you can see already the pattern is emerging that the opportunity costs are getting progressively steeper. All right. Now, how about point C, by which I mean moving from point C to D. Oh, no, we're moving, as we move from A to B, what's happening is that we're losing 2 steaks. We're losing 2 burgers, but we are picking up 2 steaks. So we're not actually doing this at a single point. We're actually doing it between 2 points. No, yes, there is a sacrifice, because to go from A to B, we lost 2 hamburgers and we picked up 2 steaks. So in other words, point A actually means in this case, we're going from A to B. All right, so we started at A, we moved to B, and in the process, we lost 2 burgers, but we picked up 2 steaks. Okay, so you have to think about it as not being at a single point, but moving from one point to the next. Okay, so there's always a change. One of them will go up, the other will go down. They can't both go up, and they both can't go down. All right, so in this case, from C to D, so now we moved from here to here. The sacrifice of the burgers is now up to 6. The gain of the hamburgers is still fixed at 2. So that suddenly moves us up to 3 hamburgers per steak. And then one more, point D, which means moving from point D to E, we have an opportunity cost of steak equals 8/2, which is 4 hamburgers per steak. All right, so that takes care of that. That was the whole thing. We just needed to calculate the opportunity costs and draw a picture. So that was pretty straightforward. I think you'll all agree. So again, it's really just a question of lining it up correctly, and just first make sure you're going in the right direction. And secondly, just remember that it's always the sacrifice good divided by the gain good. And no matter which direction we're moving in, the opportunity cost will go up when we produce more of a good, as long as the curve is convex to the origin. If it's a straight line, then the opportunity cost will be constants. All right, so we haven't seen an example like that. Maybe I'll put one onto the sample midterm. But if we had a straight line, the opportunity cost would be the same all up and down that same curve, because then we're looking at the slope of the curve, which is never going to change if it's a straight line. All right, well, that one was pretty easy. Maybe, hopefully the test will be like this. Well, yeah, of course it'll be like this, but not identical. So, all right, let's move on to the next one. Which is number 4. So we'll go to chapter 4 problem set. And let's take a look at this. What's today? The 15th again. All right, so these are our supply and demand questions. Now, of course, supply and demand is really at the heart and soul of all of economics. Now, for many of these questions, it does not explicitly say that you must draw a graph. But in my opinion, in many of these cases, that is the best way to get your answer. Okay, so in other words, even when it doesn't say draw a graph, maybe you should think about drawing a graph because it'll help you visualize what we're doing. So here, for example, if you look at these, you'll see that they want to know in part 1, what is the impact on equilibrium price and quantity of the following 4 factors or changes? So let's start at the beginning with number 1, A rather. And all right, we'll do these all together in one shot. So I'm going to draw the pictures. Like I said, it doesn't mention that, but I'd like to make sure we all understand what's going on here. So imagine we start out with our traditional supply and demand curves, and we see that there's an increase in demand. So let's say initially we have our first equilibrium, we'll call it 0.1, and the price and quantity are P1 and Q1. If there's an increase in demand, that of course means that the demand curve will shift to the right. Okay, so what was the effect of all this? Well, first of all, let's label this as an increase in demand. And the 2 things that we needed to notice are the price went up and the quantity went up. That's really the bottom line. Okay, so you can see that an increase in demand caused the equilibrium price and quantity to both go up. Now for part B, there's a decrease in demand. Now it should be pretty clear that this will just be the opposite case. Yeah, because it doesn't explicitly say you must draw a picture. So therefore, a verbal answer would be fine. But if you're not sure, you might want to draw a little picture anyway, even if you don't hand it in. Okay, so decrease in supply is demand rather is just the opposite. Everything works in reverse. Okay, it looks like there's not enough room here. Let me just move this down. All right, so let's draw this thing. So we start at the same point. And now we shift the demand curve to the left. Okay, so the bottom line is the price dropped and the quantity dropped as a result. Okay, that's really what we're aiming for. Okay, so in fact, what you could do, and I'll add this here too, I'll just type it out. The price increased and the quantity increased. Whereas down here, it's the other way around. All right, that was A and B. Now C requires us to consider an increase in supply. All right, so let's see how that looks. Oh, sure, yeah. All right, so we'll wait for everyone to catch up and then we'll carry on with the increase in supply. Oh, you got it. Okay, good. All right. Now let's look at an increase in supply. And of course that means, now by the way, increase always means shift to the right. It doesn't matter if it's supply or demand. So the new equilibrium, the intersection between the new supply curve and the original demand curve, you can see, wow, this is a nice setup. The price went down and the quantity went up. Oh, I forgot to label it. Increase in supply. So the bottom line is that the price went down and the quantity increased. Okay. All right, and then lastly, for part D, we need a decrease in supply, which clearly will be exactly the opposite case. Okay, so the intersection between the original supply and demand curves is here. And over here is the new position. So you can see here the opposite happened. P went up, Q went down. Okay. So we can see here that the price increased and the quantity decreased. Okay, so that takes care of all four of those. Now, I do want to point out here, just in case you forget, just as a side note, Note, when demand changes, both the price and quantity move in the same direction. Okay, either they both go up or they both go down. But when supply changes, the price and quantity move in opposite directions. Just a little helpful reminder. Okay, now let's look at question 2. First, what is the relationship between quantity supplied and demanded when there is a shortage of the good? Well, let's draw a picture. Again, it doesn't say you must. Let's try it though. So a shortage means, remember the word shortage indicates that the quantity demanded exceeds the quantity supplied. That can only happen down here if the price is too low to be in equilibrium. So clearly this is our equilibrium price. I'll just call it 1 is fine. P1, Q1. Let's call this P2. At P2, you can see that based on these curves, the quantity demanded exceeds the quantity supplied. And the difference between these 2 points, I'll call that Q D and QS. That is my shortage right here. And that just means that people want to buy more of this good than is being made available at that price. Okay, the price is too low. People are scooping it up. It's disappearing from the shelves. And before you know it, it'll be back, but with a higher price. So the answer, though, the actual final answer is quantity demanded exceeds or is greater than quantity supplied. Okay, so remember the graph wasn't asked for, but it might help you visualize this. But the bottom line is that the quantity demanded exceeds the quantity supplied when there's a shortage. Now, the next part asks us the follow-up question: what happens to the price of a good when there's a shortage? So we don't need another graph for this. When there is a shortage of a good, the price rises. Okay, it has to, because the producers are well aware that this is going on and they don't like having a shortage. They want to make more money, so they raise the price. And that will take care of the problem. Now, the surplus case is the opposite of the shortage. Of course it is. So that's when too much is being produced at that price. So you've got this situation. Here's 1. And for some reason, the price is up here somewhere. So here you can see, by looking at the curves, the quantity supplied exceeds the quantity demanded. And so the bottom line is that when there's a surplus, oh, and by the way, this is the surplus right here. More is being produced than people want to buy at such a high price. So the reaction to that, as we'll see in part D, is that the price will drop. Okay, so when there is a surplus of a good, the price falls. Now, it won't just keep falling and falling. It'll fall until it hits the equilibrium price. Okay, then there's no reason for it to change any further. All right, so in other words, they won't move it down here somewhere. It'll keep dropping until we find the equilibrium, and we'll know that we're in equilibrium when the quantity supplied now equals the quantity demanded. All right, what could be next? What are 3 factors that can increase the demand for a normal good? All right, well, there's a lot of them. There's more than just 3. So what you would do is you pick 3 of them, but I'm going to list some more just in case. And so, yeah, these are the basic 6 that we saw in the notes. So I'll just list them all, and then you can pick any 3 of them if this shows up on the test, right? So we have an increase in the taste for the good, an increase in consumer income. Now, obviously, that's why I mentioned specifically the word normal, so that we don't have any confusion here. Obviously, if this was an inferior good, then this same increase in consumer income would actually reduce our demand for that good. What else did we look at? Oh, an increase in the price of a substitute or a decrease in the price of a complement. Now, of course, for these, you might want to throw a little example in there because it's easy to forget how this works. For example, an increase in the price of Pepsi increases the demand for Coke. And that's because they are substitutes. On the other hand, an increase in the price of French fries decreases the demand for ketchup. And again, because they are complements, which means they're consumed together. So now, again, it doesn't specifically ask for examples, but if you're forgetting or if you don't remember or understand, often an example can be very helpful. What else do we have? The expected, and again, remember, we only need 3, but, I want to list them all. The expected future income, future price of the good increases. Okay, in other words, if you really believe the price will go up in the near future, you'll want to buy more of it today to avoid the price increase. Okay, now, the 5th one was the number of consumers in the market for the good increases. And then finally, number 6, expected incomes and or credit increases. In other words, if you expect to have more purchasing power in the future, you will certainly buy more of every product today. Like when you're about to graduate from college and you have a credit card, you might say, there's all these things I've always been wanting. Maybe I'll just buy them now before, even though I don't have that first job yet. All right, now, how about the factors that increase the supply of a good? All right, well, let's think about these. Again, there are 5. This time there's 5, but we only need 3. But let's just mention them for now. Okay, yeah, those are all very important ones, absolutely. Higher technology, lower input prices, and lower prices of related goods. Those are all definitely factors that increase the supply of a good. All right, so let's just start listing them all here. So one would be productivity improves. Now, if you wrote technology improves, it amounts to the same thing because technology makes productivity higher. That's the point of it, all right? It's kind of like, imagine that you were working on this test and all of a sudden you got transported back in time by accident to 1970 and you don't have a calculator. Well, how much longer would it take to finish the test without your calculator? Well, I don't know how much longer, but certainly it would be a slower process. So technology makes it possible to have higher levels of productivity, which increases the supply of all goods in the economy. All right, Input prices decrease. And that, of course, means land, labor. Well, in the resources that we normally think about are land, labor, capital, and entrepreneurship. If rent, wages, interest, and profits are lower, then supply will increase. Although I guess maybe that doesn't really work with entrepreneurship. We'll stick with land, labor, and capital. How about that? Because the capitalist is the one who actually keeps the profits. So if the resources are land, labor, and capital, so therefore if rent, wages, and interests are lower, we would expect to see an increase in the supply of a good. Because it's cheaper to make it. It's that simple. All right, what else do we have in our list? Oh, a decrease in the price of substitutes in production, or an increase in the price of complements in production. All right, now that's, keep in mind, this is from the perspective of the producer. So everything here works backwards from what we saw with the consumers, right? Way up here, we have an increase in the price of the substitute or decrease in the price of the complement. Here it's the other way around. Okay, why is that? Okay, like for example, if the price of corn falls, the supply of wheat will rise. Why? Because they can basically be produced with the same resources. If the price of natural gas increases, supply of crude oil will increase. As we've discussed previously, natural gas is produced as part of the process of drilling for oil. All right, what else could we throw in there? Oh, the price of a good is expected to decrease. This is again the opposite of what we had earlier. Expected to decrease in the future. So we want to sell more of it now while the price is still relatively high. And then finally, just like with consumers, the number of producers in the market, or the number of producers, I should say, of a good increases. Okay, those are done. Now, finally, this last one is the first one that actually asks you for a graph. All right, so you want to be ready for this. You want to get some practice. Don't assume that you know how to do this unless you had some practice. It may not be quite as simple as it looks. So what are we being told here? We're looking at the impact on the equilibrium price and quantity of a normal good following an increase in consumer incomes. So that clearly would affect the demand for this product. And in fact, since it's a normal good, that means the demand will go up. All right, that's all you need. It doesn't ask for any explanation, but this time it just asks for the graph. So you can draw the graph showing the supply curve shifting to the right. Okay, so the the demand curve, what am I saying? The demand curve shifts to the right when incomes rise, since this is a normal good. All right. So that was relatively painless, I thought. Now, like I said, I will be posting the sample midterm later on today. And it'll be pretty much the same, except that it also includes chapters 1 and 2, which this doesn't really, mainly because chapters 1 and 2 don't really have a lot of actual problems. It's more definitional. Oh, yeah, go ahead, Noah.
When will the midterm be assigned?
Probably at the end of this week.
Will we have a week to do it like with the math midterm?
Yes, you will.
They're just confirming.
Definitely. You'll have a full week to do it. Okay. So let's put these away now. And I'll post these as well, of course, these solutions. So you obviously need to have these solutions in order to answer the questions on the test. So hold on one second. There we go. All right. You know what that means? We're completely done with chapter 7. So we're ready for 8. It's kicking around here somewhere. 8 is a very different topic. It involves labor. Okay. Now, labor, of course, means work. You and I are laborers. We work, we get wages. Unless you're independently wealthy for some strange reason that you just feel like going to school anyway, then we're going to all be working for many, many years. And so we want to analyze how wages are determined in the marketplace. I don't remember. This one may not be posted either. I'll take care of that when we're done. Hold on a second. I'm just going to make a note to myself. All right, so just in case they're not there, I'll go double check and make sure everything's there that we need. So here's 8. Oh, I forgot. We still had one. Okay, sorry. I thought we were going to be looking at wages today. No, this is a follow-up to what we were doing earlier with potential GDP and the natural unemployment rate. 7 was our discussion about inflation, which we're completely done with, by the way. We did go over these. We went through CPI and we went through how inflation is calculated. So then, and we went through some other alternatives. All right, so I'd forgotten about this. I think 9 is our discussion about labor. So we're going to be looking at instead a closer look at GDP, and we're going to get into some economic theory here. So we're looking at potential GDP and the natural unemployment rate. Now, you might recall we discussed this once before. Potential GDP really means that we've reached the level where there's no cyclical unemployment. All right, let's remind ourselves what this actually means. So potential GDP is reached when there is no cyclical no cyclical unemployment. Okay, in other words, the only unemployment in the economy is either structural or frictional. Okay, so we went through this in what chapter was that? 6? Yes, let's go back and revisit this. Way at the end here, there it is. The different types are considered to be frictional, which means people are temporarily between jobs. Now, there's nothing much we can do about this. Policymakers, which we'll discuss later on in the course, do not have the ability to change the amount of time that it takes for people to find jobs. This is really a function more of technology. In other words, you'll find this out pretty soon. It used to be that in order to find a job, you had to actually go to a newspaper and look at the listings, and then you would call these different companies and try to convince them to give you an interview. Now, look how easy it is. You go to a place like monster.com and you post your resume, and then people find you based on the keywords in your resume, and then they hopefully contact you and offer you an interview where you get a chance to prove that you are exactly who they're looking for. All right, so the technology has definitely reduced the incidence of frictional unemployment. So especially for very specialized jobs. In fact, there are commercials going on right now. I've been seeing them for this place called Indeed. And people who have these very specialized jobs are looking for people, and they're finding it very difficult to find them. But with Indeed, of course, this is what the commercial is all about. Indeed comes to the rescue and makes it possible to find and identify the best candidates very, very quickly compared to, let's say, 20 or 30 years ago when we didn't have the internet. Now, it's hard to believe, but the internet hasn't been around forever. It's been around for your entire lifetimes, but that doesn't mean it's been around forever. Okay, for the most part, people started getting the internet on their computers in the early to mid 90s. And at the time, there wasn't a whole lot of content on the internet either. It wasn't that useful just yet. It took a while to catch on. So frictional unemployment just means you're temporarily in between jobs, you're searching, and you will get one eventually. It's just a question of how long it takes. This has nothing to do with interest rates. This has nothing to do with GDP growth. This is just a fact of life. It takes time to find a new job, either when you graduate from school or else you have just lost your old job. The other one, remember, was structural, which means that these are people where their skills are poor. They may not have very much education, for example, or maybe they don't speak English, or maybe their writing skills are extremely poor, or they can't read very well, or they just don't have a whole lot of training. There's a lot of reasons why this could happen to people, or in some cases, maybe they had a skill that became obsolete. That happens too. Through no fault of their own, the industry they worked in became obsolete, and now they've got to look for something else. Same reasoning here. This is not related to interest rates. It's not related to the GDP growth. These are people who need more training in order to find a job. But the one that we're focused on here is cyclical. These are people who should normally be working, but the economy is in a downturn, and so therefore their jobs have disappeared. And so we call these people cyclical unemployment. Now, when the Federal Reserve cuts interest rates, as we'll discuss later on in the course, one of the reasons for doing that is to help these people get back to work. Because lower interest rates means businesses can afford to expand and hire more people, and they're hoping that that's exactly what will happen. When it reaches the point where there isn't any cyclical unemployment, then we have reached what's called potential GDP, meaning this is the best it can get with the resources that we have. Just like as an individual, there's some limit to what you can produce during a given year. There's only 24 hours in a day. It's like, imagine if you were a writer, a novelist. Well, let's just say that you spend the whole year writing novels and you never waste any time. And let's say by the time the year's over, you have written 4 novels. For you, that's your potential output. The only way you can't improve on that unless something changes like technology maybe, but that's the best we can achieve. And the unemployment rate that occurs at this point, which you might also recall, the natural rate of unemployment is the rate of unemployment that is reached or achieved when the economy is at potential GDP. All right. So once we reach that point, whatever unemployment is left, this rate only includes cyclical and it only includes structural and frictional unemployment. Now, I think we mentioned in the other lecture, that this number is controversial. For many years, in fact, decades really, it was always believed that this rate would be around 5%. But now we've seen that that's not necessarily true. How do we know that? Because last year, before the COVID broke out, the unemployment rate had fallen to 3.5%. And it had been there for a while. And so the thinking now is that the natural rate is lower than it used to be. And, one potential explanation for that is advances in technology. Well, that would be nice. So anyway, what we're going to see here, though, is different viewpoints from these different economic schools, as they're called, about what exactly is it that causes unemployment in the economy and what adjustments take place as a result. Now, economics, the one drawback to economics is that unlike a hard science like physics or chemistry, you can't actually conduct experiments. Like if a physicist says, listen, I want to know what happens if I combine these two atoms. Well, you can find out by conducting an experiment. That isn't the case with economics. For example, suppose the Fed says, listen, we want to find out what happens if we lower interest rates by a full percentage. Well, what happens then is that they can't control the rest of the economy. In other words, they may find that the economy is stimulated, but that might be caused by other factors besides the interest rate cut. So what that means is there's a lot of theories as to how and why all of the economy operates. And so some of these are more, well, let's just say some of these are better known than others. But there's three very important schools of thought. And they're called, as you can plainly see, the classical school, the Keynesian school, and the monetarist school of macroeconomics, each of which has its own ideas about what is it that causes inflation and unemployment, et cetera, and what can be done about it, okay, if anything. Now, you may not be familiar with these names. In fact, you know what? I think I might have some videos about these three schools, which let me hold on 1 minute. Let's see if I can, I'm going to dig into my archives here, because I'm pretty confident that at one point in time, I had discovered some videos about these three schools of thought. And now, let me see if I can identify them. Oh, all right. Well, there's one here. Maybe we'll look at this one. How about that? It says specifically the natural rate of unemployment. I'll tell you what, let's check this out before we dive too deeply into this topic. I find that this particular source, Marginal Revolution University, does a very nice job with these videos. So let me send this off to you and we'll take a look at this before we get started. Hold on 1 second. As usual, I will send it to you by the chat box. And of course, I will stop the sharing to avoid any potential copyright problems, all right? So let's check this out. All right, are we all basically done? That's good because I did find one of the other videos that I wanted to show you before we start introducing these different theories. I think it would be nice if we could watch this background video. It'll help you understand a little better what exactly these economists were writing about and why they disagree with each other. A lot of this has to do, it's sort of a philosophical thing, the way we think about the way the economy works and what's likely to help and what's not likely to help. Just like a lot of other areas, social sciences, there's a certain amount of philosophy involved. And so these different schools have arisen that attempt to explain how things work, but from different perspectives. Okay, so I'm going to show you this one next. We're introducing here the so-called monetarist school. And it's a very interesting idea. So let's take a look at this and then we'll look at a few others and then we'll discuss them. So here's the video here's the link for the monetarists. All right, let's check this out. All right, we all done? All right, there's another one. This is sort of a follow-up. You'll see right away it's the same people who made this. This is now the perspective of the Keynesians. They did mention Keynes in the other videos very briefly. Keynes was writing during the Great Depression when the top priority was getting the economy back on its feet. So his perspective is a little bit different, but he was of the opinion at that time, at least, that it was much more important to reduce the unemployment rate than to worry about inflation, because at the time the biggest problem we had, of course, was unemployment. So his theories are based on that background, but still a lot of what he did is taken seriously today. But he's looking at things in a slightly different way because he has a lot of trust in government to make things better through either increasing spending or cutting taxes. So we'll take a look at this one now. All right, there you go. Let's check this out. Okay, is everyone done? All right, so I think that's enough for today. So that was a good background for where we're going now in this chapter. We're going to be comparing these these multiple theories, and see how they each attempt to explain what's going on in the GDP and unemployment rates. So, all right, so I'll tell you what, now don't forget, what we want to do is on Thursday, I'll post the sample midterm and we'll go over that on Thursday. And then I can give you the actual test, which you'll have about a week to do. All right. So I'll see you all on Thursday.
Bye.
Bye. See you later.
Thank you.
Bye, Professor.
See you later.
Thanks.
Bye.
See you later. Thank you. You're welcome.